Welcome to a basic example of integration by parts. We have the integral of 3x times e to the x integrated with respect to x. Integration by parts is often helpful when we have a product of two functions in the integrand. The integration by parts formula is the integral of u dv equals uv minus the integral of v du. Before we apply this, let's look at some recommendations when using integration by parts. When the original integral is in the form of u dv, we want to choose u so that du is simpler than u. And number two, we want to choose a dv that is fairly easy to integrate. Notice once we assign dv, we have to integrate both sides of the equation to find v. So going back to our example, let's let u equal 3x. Notice how the derivative of u is simpler, it's just a constant. And let's let the remaining part, e to the x dx, be equal to dv. Notice here, e to the x is going to be easy to integrate. So if we let u equal 3x, then differential u would just be u prime times dx, or just 3 times dx, or 3dx. And if dv is equal to e to the x dx, we need to integrate both sides of this equation to find v. Let's go ahead and show that. The integral of dv, or 1 dv, equals the integral of e to the x dx. We can think of this as 1 dv. The integral of 1 with respect to v would just be v. The integral of e to the x with respect to x is just e to the x. And we'll leave the plus c for later. So now we know that v equals e to the x. This is the information we need to apply the integration by parts formula. So the given integral is equal to u times v minus the integral of v du. Well, u times v would be 3x e to the x minus the integral of v du, which would be e to the x times 3 dx, or 3 e to the x dx. Notice how this integral here is much easier to integrate because we don't have this extra factor of x in the integrand. The integral of 3 e to the x with respect to x is just 3 e to the x. So the antiderivative is 3x e to the x minus 3 e to the x plus c, which means the derivative of this family of functions will be 3x e to the x. And if we want to, we could verify that. I hope you found this helpful.